Assalamualaikum warahmatullahi wabarakatuh to my fellow panels and everyone. I hope everyone doing well during this challenging time. My name is Hafizah binti Abdul and I am under supervision of Dr. Ahmad Khushairy and Dr. Fazli. In this video, I will be presenting about my research in monitoring diverse heart rate response using heart rate detection device. Did you know that Malaysia hit 28.2 million units of vehicles on the road based on Malaysian Vehicle Registration data prepared by the Malaysian Automotive Association (MAA) up to June 2017? With increasing of total vehicles on roads, it leads to increasing the road accidents and heavy traffic road. Car crash or road accidents can be described as unintended incidents to happen due to lost driving control until collision with other vehicle, property or other road users that causing injury to driver and passengers or even damage to public property. MIROS, or known as Malaysian Institute of Road Safety Research, identified that accidents and injury caused by environmental aspects, engineering and human error. 94% of road accidents were contributed by human errors, while the rest due to engineering and environmental aspects. Types of human errors are sleepy or drowsy driving, poor directional control, misjudgment of gap, speeding, inadequate surveillance, and driver's inattention. Hence, this study is inspired by one pillar of Road Safety Plan of Malaysia, which is safer road user, as responsible parties are less involved and exposed in any effort to reduce the rate of road accidents. Besides, a warning system device in alerting the drivers about their drowsiness during driving has never been appropriately developed. Therefore, this study will contribute to a new finding to understand the driver's heart rate response and behavior during driving by using driving simulator. Research questions of the study are: number 1, what parameter can be analyzed from the drivers that are experiencing drowsiness? Number 2, how the heart rate detector works on drivers? And number 3, what is the performance of the heart rate detection device to the drivers?
In this study, there are 3 objectives. First of all, to identify the drowsy heart rate mean value of drivers during driving the car simulator by using heart rate detection device. Next, to develop or create a warning device that able to monitor drivers' heart rate and notify them about their drowsiness through the heart rate detection device. Last but not least, to examine the effectiveness of the designed heart rate detection device in terms of ability to monitor the heart rate readings and produce alarms. This study will focus on developing a device for heart rate detection system which is running by Arduino software and creating a warning alarm system to notify the driver about their heart rate reading if reaching the lowest limit of normal heart rate. In order to obtain the result, 10 volunteers, 5 male and 5 female students with a valid driving license in age 24 had been attached with heart rate detection device for 4 30-minute session on driving simulator. For this case study, the result obtained may not applicable to other types of sensors used. Hence, this research is only limited for persons who free from critical disease and not taking any regular medication. Besides, the experiment will be conducted only on simulator driving condition, as real driving situation has a high probability for road accident to occur. These are the keywords that summarize previous research which allowed me to identify relevant theories and methods.
Driving is an action of someone controlling the operation and movement of a vehicle. Meanwhile, drowsiness refers to feeling abnormally sleepy during the day. Drowsiness driving has been recognized as one of most phenomenon in contributing to road accident according to the National Transportation Safety Board. In US, 29% of drivers reported that they are nodding off during driving. In a nutshell, drowsiness will affect the performance capabilities or person determination in order to maintain the level of awake alertness. In Malaysia, 2 years ago, A bus carrying 43 foreign workers involved in accident and caused 11 deaths, including the bus driver, while others were injured at Jalan S8 Pekeliling KLIA. Based on the accident, Tan Sri Lilam, which is one of the National Road Safety Council members, commented that sleep cycle microsleep also happened during daytime as well, and commuting accident is a rising trend in Malaysia. Heart rate is known as the amount of times heart beats per minute, BPM. Generally, a normal heart rate range for adults is 60 to 100 BPM. It is one of the standard primary vital signs along with respiration rate, blood pressure and body temperature. Heart rate is categorized as physiological signals which are more suitably used to detect drowsiness because sleep rhythm is strongly connected with brain and heart activities. Previous research indicates that BPM decreased significantly in drowsy driving by 9.3% when compared to overall driving BPM, as when a person becomes drowsy, it reduces BPM, which occurred due to activation of parasympathetic nerves. It is dangerous to drive while drowsy, as drowsiness is one of the sleep deprivation symptoms, together with nodding off for brief intervals while awake, microsleep, and easily falling asleep within a few moments of lying down. Apart from physiological measures, behavior measures such as chatting, yawning, eye closure, and head position would determine the driver's driving state, either alert, drowsy, fatigued, distracted while driving. Thus, KSS or Karolinska Sleepiness Scale has been frequently used in research on shift work, sleep deprivation, and driving. Based on previous research, data gathered from KSS can be retrieved and used to categorize driver state or assess driver abilities. KSS is a 10-point scale starting with level 1, which is extremely alert, and last one is level 10 for extremely sleepy and cannot keep awake. KSS able to assess the individual's drowsiness and show which level best corresponds to the psychophysical state experienced, with implying that decreased performance is related with greater KSS value. The heart rate detection device consists of a pulse oximeter that determine the heartbeat and oxygen saturation level of an individual's blood. The proposed system is based on the infrared working system by sensing the luminosity absorbed by the blood in capillaries beneath the skin. It is positioned on the person's fingertips as shown in the figure and detects the heart rate before transmitting the data to the Arduino controller. The rush of blood generated by each heartbeat produces a signal indicative of the individual's heart rate. This section explains the flow of this research to achieve the objectives. The development of heart rate detection device starting from selecting component, computing coding, and assembling the device is to fulfill objective number 1, which is to identify the drowsy heart rate mean value of drivers during driving the car simulator. Next, developing a warning system in the heart rate detection device by set a threshold based on the calculated heart rate mean. So, the device will produce an alarm beep to notify the driver about their drowsiness. After the device construction process is complete, proper planning is required to guarantee that the experiment works as smoothly as planned. This experiment is designed to assess this hypothesis. Number 1, the driver will be drowsier as time of driving increases. Number 2, the longer time driving increase the frequency of driver's behavior sleepiness scale. Number 3, heart rate detection device has an impact in alerting driver with drowsiness driving. The third objective is achieved by conducting a performance analysis of the heart rate detection device with qualitative research questionnaire that use Likert scale questions. With these skills, respondents are asked to rate the device based on their level of agreement. Once the experiment is successfully conducted, the collected data will be analyzed by using the repeated measures ANOVA through IBM SPSS statistics to determine the significance of the data. The outcomes were classified into 3 categories. Number 1 for heart rate response, followed by the Karolinska Sleepiness Scale, and lastly HRDD's performance or heart rate detection device performance. The line graph illustrates the average value of heart rate between male and female respondents for 3 sessions. From the graph, we can see that both genders' heart rate slightly fall from first session to third session. Meanwhile, this column chart shows the average value of heart rate between respondents in 3 sessions. As we can see that the heart rate of each respondent fluctuates from one session to another. Based on the line graph, the mean heart rate for 10 respondents show a little drop from session to other session. The drop was not statistically different due to short experimental duration, which is 30 minutes per session, compared to experiment conducted by previous study, which required 2 hours non-stop session. This will influence the mean value of heart rate as the longer period of experimental duration will show a clear fall of driver's heart rate. Besides that, during the experiment, possible interruption occurred, such as failed connection of device that affected the quality of results obtained. For Karolinska Sleepiness Scale, the mean value of KSS level by gender, as shown in the line graph, gently went up till the end of third session, while the column chart represents the mean value of KSS level for each respondent according to the sessions. There is some respondents that show an inconsistent increment for the KSS level. If we look at this line graph, you can see that the mean value of KSS level likely rise from session 1 to session 3 for 10 respondents. Even the graph presents insignificant differences, the KSS level increases as the drivers continues the next session. This is possibly because of the small sample size which focus only on 10 respondents and unstandardized driving route as it was a free roam route. Each respondent experienced different feelings or situations when driving based on their own road preference. Results for the performance of heart rate detection device were divided into 2 parts. First, the KSS data obtained from the third session is compared with fourth session, where the heart rate detection device was set with the calculated threshold value for alarm to be activated. As you can see from the line graph, I would like to focus your attention on steeply decreases of KSS levels mean value from third session to fourth session. This provides evidence that the alarm able to notify the driver about their drowsiness, which lowering the KSS levels mean value. The second one, the bar chart, show a statistically significant of device performance that obtained from the 5 answered questionnaire. The rating scale questions that been asked to the respondent were: number 1, did the position of heart rate detector distract the driver during driving? Number 2, did you satisfied with the device performance? Number 3, did the alarm produced by buzzer make you awake? Number 4, did the device give a quick response? And lastly, did you think this device will help to overcome sleepiness while driving? As the respondent selected the number in a scale of answer option from range 1, strongly disagree, to 5, strongly agree, that most accurately represent their response, 4 out of 5 questionnaire obtained significance mean value. Therefore, the null hypothesis was rejected for this session. I would like to summarize by saying this research identified that driving for a longer period of time will cause drivers' heart rate to decrease and KSS level to increase. Besides, the heart rate detection device was successfully operated in monitoring drivers' heart rate response and notified them about their drowsiness. To end, I would like to highlight recommendations that might help for future research. Number 1, increase the size of sample and experimental duration to establish a greater degree of accuracy on significance difference. Number 2, upgrading the device with printed circuit board PCB for better current carrying capacity. And lastly, using a driving simulator with advanced system of vehicle-based metrics such as pressure on gas pedal and movement of the steering wheel for strengthen the results obtained. And on that final note, that concludes my presentation. If my fellow panels have questions, please feel free to contact me at this email or number. And that brings us to the end. I would like to thank you for your time and attention for today. Have a nice day. Goodbye and Assalamualaikum.